All right, in this video, we're going to do a couple examples of solving a quadratic equation using completing the square. Step number one when completing the square is you want to isolate the terms with variables on one side of the equation and arrange them in descending order. You want your x squared, then your x on the same side, and then everything else over to the other side. A little bit different than when we actually factored, right? So we want to bring that number that's by itself, that has no variable, over to the other side of the equation. We're going to divide both sides by the coefficient of x squared if that coefficient is not 1. So if the number in front of x squared is not a 1, then we have to get rid of it first by dividing all our terms by that number. Then we're going to complete the square by taking half of the coefficient of x, squaring it, and adding it to both sides. Remember, we did that in the last video. We should then be able to take that factored version of our perfect square and write it as a binomial squared. We should then be able to square root both sides to solve, and then we can solve for x to finish off. Let me show you a few examples here. Here's example number 8, and then we'll do number 9 also. On this one, it asks us to solve. We have a t squared minus 10t plus 23 equal to 0. If I try to factor it, I don't think there's any numbers that multiply to 23 that when I add them together, I get negative 10. So I wouldn't be able to solve by factoring. So that's when we know we have to use completing the square. Remember, the first step is to move all of my variable terms over to one side, everything without a variable to the other side. So in this case, I'm going to take that 23 and I'm going to subtract it over to the other side. When I do that, I end up with a t squared minus 10t equal to negative 23. And you notice I've left some space because at the next step, I want to figure out what I need to add to both sides in order to make that left side that perfect square. So we talked about in the last video how to figure out what that number is. Remember, we take the number that's in front of the x, or in this case t, negative 10. We divide it by 2, so what's negative 10 divided by 2? Negative 5. And then we take that negative 5 and we square it. So what's negative 5 squared? Well, negative 5 times another negative 5 is a positive 25. So that's the number we're going to add to both sides. So I now have this equation that says t squared minus 10t plus 25 is equal to negative 23 plus 25. Don't forget to add it to both sides so that your equation is balanced. All right, now if you look at the left side should be a perfect square. Numbers that multiply to positive 25 that add to give us negative 10 should be t minus 5 and t minus 5, right? And then on the right side, I can combine those like terms and say that negative 23 plus 25 is really just a positive 2. Now, the left side should be that perfect square. So instead of writing that t minus 5 twice, we should be able to write it as a binomial squared. T minus 5 squared, right? Because there's 2 of them. And now we can use our principle of square roots, and we can square root both sides to get rid of that square. Remember, the square and the square root cancel. Do you also remember the other rule anytime we square root? Yeah, make sure you add plus or minus. So I end up with a t minus 5 equal to plus or minus the square root of 2. Now, square root of 2 can't be broken down any farther, so I'm going to go ahead and leave it like that. But I'm not quite finished solving for t. I still want to get that minus 5 away. So let's go ahead and add it to both sides. Be careful not to combine the 5 and the 2 because they're not like terms. But I can go ahead and say then that t equals 5 plus the square root of 2 and 5 minus the square root of 2. That's 2 answers. Remember, I knew that because it was a quadratic because of my t squared at the beginning. I have 2 answers, 5 plus or minus the square root of 2. Now those 2 answers are in what we call exact form. We haven't put it in our calculator and rounded to a decimal. But if they asked me to, we could. We can do 5 plus the square root of 2 and 5 minus the square root of 2, and then round depending on what they said they wanted us to round to. I think if I did it correctly, I'd got a 6.4 and a 3.6. So 2 different numbers that t equals in order to make that equation true. All right, let's do another one. Example number 9 says find the x-intercepts of the graph. So it gives us a function now. F of x is equal to x squared plus 10x minus 2, and it asks us to find the x-intercepts. Where does it cross the x-axis? Now remember, we talked about this at the beginning of the section, how to find the x-intercepts. We also talked about this when we were graphing. Well, we can actually find the x-intercepts of any graph by plugging in 0 for y. or in this case, f of x. So I can figure out where this quadratic equation equals 0. Now if you look, if I try to factor, there are no numbers that multiply to -2 that are going to ever give us 10. So factoring wouldn't quite work here. So that's why we have another technique, completing the square. Let's try it. I don't know about you, but I always like to see it in a different order. So I'm going to actually put the x squared plus 10x minus 2 on the left side and then the 0 on the right side. I haven't done anything. I've just written it in a different order, switching the sides. For whatever reason, I like to see it in this order. You don't necessarily have to do it, but it's kind of a habit of mine, and so I'm going to kind of keep it this way. For completing the square, remember we want to keep the x or the variable terms on one side and the numbers without an x on the other side. So you notice that I've taken that -2 and I've added it over to the other side. I now have an equation that says x squared plus 10x is equal to 2. I've left some space because I want to figure out what number I need to add to both sides so that I can complete the square. I can write that left side as a perfect square. So let's take the number in front of x, that's 10, divided by 2, which is 5, and square it, which is 25, and add that to both sides. Make sure you do it to both. Now we should be able to complete the square on that left side. Numbers that multiply to 25 that add to 10 are 5 and 5, or I can say x plus 5 squared. On the right side, 2 plus 25 is 27. So now I have this equation. It's still a quadratic equation with a squared in it, so I know I should still have 2 answers. And now I can use my square root to get rid of that square, making sure I square root the other side, making sure that I add plus or minus. And if you've noticed, I also broke down the radical. Now there isn't an even square root of 27, but I can break down that radical into 3 rad 3. So that's what I'd like you to do. Just like if you were to give me a fraction, I would always want you to reduce your fraction. Well, I always want you to break down your radical also. So we have x plus 5 equals plus or minus 3 rad 3. Let's finish it off by subtracting 5 to both sides, and then we can say that our 2 answers, x equals -5 plus 3 rad 3 and -5 minus 3 rad 3. There's some sort of a decimal, but those are the 2 places that my parabola, my graph, touches the x-axis. Now they're points, so I probably shouldn't have my answer as just an x equals. I should have them written as points, ordered pairs, x comma y's. So really our answer should be written -5 plus or minus 3 rad 3 comma 0. Those are my 2 points that touch the x-axis on this graph.